Welcome. I wanted to talk about the verifying identities homework that you're going to see this week. But actually, before I do, I wanted to talk briefly about the traditional homework that you might see. So after a section on verifying identities, you might be given the instructions, prove the identity, and you'd see an identity where you'd have one side and another side, and you would need to choose which side you would start with. So for example, I might start with the right-hand side today. So I have secant squared x minus secant x, tangent x. And it is the proper thing to do, or the conventional thing to do, to rewrite the entire side. And then you need to think about how to manipulate it with the goal of getting it to look like the other side. So I might turn everything into sines and cosines, rewriting this as 1 over cosine squared x minus 1 over cosine x times sine x over cosine x. Then there would be more steps to do. So I'm adding in a dot, 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 and eventually I would reach the other side. That is 1 equals 1 over 1 plus sine x. However, I made a lot of choices along the way. For example, I decided if I wanted to start with the right-hand side or the left-hand side. And I decided that my first step was going to be to rewrite things in terms of sines and cosines. But I could just have easily decided that I wanted to factor out a secant x and work with that. That was because of all the different options, it's complicated to program homework problems for proving identities, because every student could have a different but equally correct approach to the identity. Or similarly, you could have a partly correct, but then there's some errors, and figuring out how to judge that you've shown enough work and that it's correct, that gets tricky. Okay, so for our homework, they've programmed it to do something a little bit different. It starts out just the same. You're told to prove the identity, but then someone else gets to pick the steps that are taken. For example, it starts off with, we will work on the left-hand side. So this is the left-hand side, this is the right-hand side, and notice the left-hand side has been recopied for you, just like one side was copied over when we were proving it by hand. Next, they tell us exactly what to do to multiply the numerator and denominator by the conjugate. Okay, and then, well, actually now probably the best thing to do would be to go in and see how one of these programs works. So that's what we're going to do. There we go. Here is an IMathAs problem. Note that at the top, we're told what we need to prove. And it starts out by telling us that both sides are complicated. So they're just going to pick one and start us on the left. So notice this is the left. And it says, rewrite the second term using the reciprocal identity. So I look at over here, I've got two terms. I want to rewrite that with the reciprocal identity. But you might be thinking, what is the reciprocal identity? So I come back over here and I'll review the trigonometric identities that are going to come up frequently in verifications. We have the ratio and quotient identities. So tangent theta is a quotient of two trig functions, sine and cosine. The reciprocal identities get their names because cosecant theta is equal to the reciprocal of sine theta, or 1 over sine theta, and so on. And then we have our Pythagorean identities. Now there are three of those. Sine squared theta plus cosine squared theta equals 1 is the most common. And finally, we have some algebraic identities that sometimes come up. Okay, back again to our proof. So we are going to rewrite cosecant x with the reciprocal identity. So it is 1 over sine of x. And I'll hit enter. And it tells me right away that I've gotten it correct. Now notice, before I hit enter, this was blank, because as soon as I hit enter, it appeared right here. This is because some students, the preview options that they have are on small screens or just don't preview nicely. So everything that has an answer box into it is rewritten one more time with the now you have line. So it's redundant, but it's to help you better visualize. This is what I have. Okay, and now I go on and I read the next instruction. It says get a common denominator and rewrite as a single fraction. Ooh, so I look at what I have. I have a sine x and a cosine x in the denominator, and then a sine x over here. I need to add a cosine x over this side, which would then get a cosine x in the numerator. So let's type that in. I have 1 plus cosine x. That'll be my numerator, all over sine of x, cosine x. Uh-oh, it didn't like that. And I look at what I entered and I think, oh, that isn't right. I wanted it to be 1 plus cosine x in the numerator, not as a separate term. So I'll make the adjustments and enter that again. Always good to double check what you entered and see if it's really what you meant to enter. Okay, I see this has now appeared below, and I move on in the instructions. Multiply the numerator and denominator by the conjugate of the numerator. Then they add, it's a sneaky way of multiplying by 1. Okay, so that's a hint that whatever I'm going to have, it'll be the same thing over the same thing. And it's the conjugate. So the conjugate of 1 plus cosine x is going to be 1 minus cosine x. I learned from before, I need parentheses around everything. And I'll then enter that in the denominator. And there we go. I'll notice also, like, as we're entering things in until it's fully in, sometimes we get syntax errors. And that's just because it's saying, hey, you've got a trig function, but no input of x yet. Something doesn't look right. But as soon as we put the input, the syntax error goes away. Okay, moving on down. It says rewrite the product as a single fraction and write the numerator with the difference of squares identity. So as a quick review, that difference of squares identity, that's a minus b times a plus b is equal to a squared minus b squared. And I have a 1 plus cosine x times a 1 minus cosine x. So that will be equal to 1 minus cosine. Oh, I should actually write it as a difference of squares. So 1 squared minus cosine squared x all over. Then I'm just going to have one big denominator. So sine of x, cosine x times 1 minus cosine x. There we go. Oops, it didn't like that. Now, I'm pretty sure it's correct, but I also know that I'm giving this to a robot and it may not have been programmed to mark the answer that I'm writing as correct. So sometimes I need to go through and think about what can I do to adjust. And so here I'm going to just simplify. So instead of having 1 squared, I'll write it as 1. And there we go. Okay, so this was just sort of an example to see occasionally something that is correct won't be marked right as correct. And it could be because you haven't followed the instructions exactly, or it could be for something like that, that it's marked to want the simplified version of 1 rather than 1 squared. You know, if you get frustrated, this would be a great time to reach out to your instructor, say, like, at this particular step, I'm having a difficult time knowing how to input, or they're just reach out and ask for help, and we'll try and help either identify a math error, or if it's something syntactical, let you know how to fix it. We move on. It says use a Pythagorean identity, but don't change the denominator. Oops, so if I'm keeping the denominator the same, why not just copy that? And my Pythagorean identity that has cosine in it and 1 in it is sine squared plus cosine squared equals 1. Now I can subtract cosine squared from both sides, and that will leave me on this side with sine squared x. There we go, that's entered in. Our next direction is to cancel like factors in the numerator and denominator. So I check and see what I have. I have a sine squared x in the numerator and a sine of x in the denominator. So one instance of sine x should cancel. I'm also just going to copy and delete the sine, and going up above, I'll delete the squared, so I'm left with sine of x, and enter that in. I'm almost done. So it says, anticipating what you are trying to prove, rewrite the fraction as a product of fractions. So I see here, I'm going to need one fraction and then another fraction. And there's a couple of ways to do this from what I have. I could put the sign in one side, I could put the sign in the other side. So let me go, notice in what I'm trying to prove, I have a 1 over 1 minus cosine x. So I am going to enter that in. And on this side, well, that would leave me with the sine x over cosine x. Now I might be tempted to enter in tangent x, but no, there is still one more step to go. As well, in these verifications, we just want to make one small movement at a time. And that would be making two movements if I would separate it and then rewrite it. So let's just rewrite it as sine of x over cosine x. There we go, both are marked correct. And we are so close to the end, it tells us to rewrite with the reciprocal identity, tangent of x equaling this. I've just noticed an error. I wrote this homework assignment. It should actually say rewrite with a quotient identity. Well, I'll go fix that in a minute. But it is going to be tangent x. Fantastic. And if you ever notice an error like that, write your instructor and we'll try and get them fixed. And finally, I look, it says I've proven that. Well done. I started with one side. I ended on the other side. Do note a couple of things in this problem that are here to help. Down below are just some formatting instructions. So if you're trying to remember how to enter, say, a fraction that looks like this, it gives some recommendations on how to enter it in. Now, I'd like to leave you with just some comments on the skills you're building by doing this homework. When you read someone else's instructions and follow them, you are getting sharper at being able to understand math terminology and follow directions. So that is a really useful skill. It's building your math communication skills. Secondly, when it comes time after you've done the homework to practice verifying on your own, which is a really important thing. Like, don't forget to do that before you come to a quiz or exam. So verify some things on your own. You'll already have all these skills and strategies that you saw whoever was giving instructions here use that you could then apply to your own verifications. So the best way to get good is practice. But if you do get stuck, please reach out to your instructor, your classmates, or the others in the community who are there to help you. Have fun.